Good day, grade 8 students. Okay, so for today, we are going to discuss about the proof of a quadrilateral angle sum theorem. Okay, so we want to prove that the sum of the angle measurements of any quadrilateral is 360 degrees. So this is true for any type of quadrilateral, square, rectangle, kite, rhombus, or trapezoid, so whatever quadrilateral that you may have. Okay, so it's 360 degrees. So we have here the basic part of our proof. So we have here a very general quadrilateral, so we don't know what type of quadrilateral this is, so it's just a quadrilateral. Given quadrilateral quad, we want to prove that the sum of its interior angles is equal to 360 degrees. So the first part of any proof, okay, so the heart of geometry, the thing that we have to do here in our geometry class is we have to prove theorems. So we want to prove the theorem that the sum of the angles of any quadrilateral is 360 degrees. So of course, the first part of a proof is we have to plan. So our plan here is we have to draw a diagonal. Okay, so a diagonal between Q and A. So we have to draw a diagonal between points Q and A, or points U and D. And also we have to label the adjacent angles in the 2 points. Okay, so that's part of our plan. And also we have to form 2 right triangles. Okay, so these 2 right triangles that we will form, we have to add them together, and therefore we're going to get the answer, which is 360 degrees. So this is how the plan goes. So we draw a diagonal between Q and A, and therefore we have those 2 adjacent angles right there. So we have M and N, and then O and P. And we have to prove that the measurement is, of course, 360 degrees for this quadrilateral. So this is going to be a very easy proof, okay? But not all proofs in geometry are going to be like this, but this one is going to be very easy, okay? So for the first part of our proof, okay, so we have here through points Q and A, construct a diagonal. So that's part of our plan. So the proof for that is through any points there exists a line. Okay, for any points, there exists a line, and that line is line QA, or our diagonal right here. Okay, diagonal QA. Okay, and then next, okay, number 2, on quadrilateral quad, the diagonal QA connects point Q and A and creates 2 pair of adjacent angles. So that's the definition of a diagonal. So when you create a diagonal or any line, it automatically creates 2 adjacent angles. So for here we have angle M and angle P, and for the opposite side we have angle O and angle P. Okay, and then we have number 3 here. Angle M and angle N is equal to, the measurement of angle M and N is equal to the measurement of angle Q, and angle O plus angle P is equal to the measurement of angle A. So that's just simply the angle addition postulate. So angle Q is composed of M and N, and angle A is composed of O and P, those 2 angles. And then we have in triangle QUA, so the measurement of angle U, okay, so this one, in this triangle QUA, the measurement of angle M plus the measurement of angle U plus the measurement of angle O is 180 degrees because it formed a triangle. Those 3 angles formed a triangle because they measure 180 degrees, and of course they are inside a 3-sided figure, which is a triangle. And that also holds true for the triangle QDA, the one at the bottom here. So it also formed 3 angles, okay? And if there's 3 angles, then therefore there are 3 sides, and also they form a triangle that also measures 180 degrees. Okay, so we have here the 5th part. So angle M and N plus the measurement of angle O and P plus the measure of angle U plus the measurement of angle D is equal to 360 degrees. So that's just the addition property of equality. What that just simply means is we have to add these 2 angles, okay? Okay, so the measurement of that will be angle Q, and then the measurement of that will be angle A. And speaking of, that will be the substitution property of equality, number 6. So we substituted the value of M and N, and substituted the value of O and P. So we have angle Q and angle A. Okay, so angle Q and A plus U and D, we have 360 degrees, and that's of course the substitution property of equality. And lastly, if we try to rearrange those letters, we form the proof that we want. So the measurement of angle Q plus the measurement of angle U plus the measurement of angle A plus the measurement of angle D is 360 degrees through the reflexive property of equality. And the reason this is 360 degrees is because we just added the two triangles, okay, the two triangles that we have, triangle QUA and triangle QDA, and we formed 360 degrees. And therefore, if figure quad is a quadrilateral, then the measurement of angle Q, angle U, angle A, and angle B is equal to 360 degrees. So this is how we construct a two-column proof, a very simple two-column proof, okay? A very simple two-column proof for solving for the angle measurement, the sum of the angle measurement of a quadrilateral. Okay, so the first step is you have to plan, okay, analyze, and then plan ahead and draw something on the figure, draw a figure, or draw a line, or anything that will lead you to the proof of your two-column proof, or the last part of your proof. So that's it.